Hi, this is Pasha, and we are finally here with the second lecture on uncertainty, and we are right now calculating the compound error. And for that we have already seen these 6 formulas that are right in front of your screen. So here are the 6 formulas, and in our previous class we saw how to read these formulas and how to use these formulas, and we saw a few examples. And in our previous class I already said that we need to go through more examples in order to get a strong command and a good control on this topic. So what we can do here is that we can look into more examples. So there you go, here we are, we have one more example, and it looks a pretty simple question, but this is a good one to practice. So it says that the diameter of the diameter of a wire is 0.56 plus minus 0.01 millimeters. So I can say that I've been given dia as and its uncertainty as 0.56 plus minus 0.01 millimeters, and what it says is what is the cross-sectional area of the wire. So I need to calculate the cross-sectional area. So we all know that the area, the cross-sectional area, is given as pi r square, but because I've been given diameter, so I'll make my equations in terms of dia. So in place of radius I can write d over 2 whole square, and this will make my equation as area equal pi over 4 times d square. And now just put the values and get the answer. So this is pi by 4. In place of dia I can write 0.56 whole square, and that would give me my final answer as 0.2463 millimeter square. Alright, and now it's time to figure out the error, the uncertainty in the calculation of area. So this is the equation that I have. Alright, area equal pi over 4 times d square. I have these 6 equations available, and I want to figure out that which one is the closest equation. So I can see that this equation number 6, the last one, is the relevant equation that I can use. Why? Because see, this equation has some constant in it, and also my equation has a constant, that is pi by 4. Secondly, my equation has a variable that has some power. And you see, here I also have, let's say here x with some power p. The only difference is that in this equation I have like 1, 2, 3, you see x, y, z, 3 variables. But in my equation I have only one variable. That's not an issue. If I do not have, if I have only one variable, I will only use the fractional uncertainty of that variable, which is d, and I will ignore the others. So let's see what I'm going to do here, how I am going to make the equation for the uncertainty. I would write uncertainty in A over A equal plus minus, I will ignore this constant because you see in my final equation I have constant in my equation, but in the equation of uncertainty there is no such thing as constant. So I will ignore constant, and then whatever is the power, you see the power of d is 2, that will get multiplied. So I will multiply 2 with the fractional error of d. Look at the example here. Here x has a power p. So you see the power p is multiplied with the fractional error of x. Similarly, here in my case, in my example, I had a square only, so I have multiplied the power, which is 2, with the fractional error of d. And because I have no other variables, so my equation will end here. If I had more variables, I would have also added the fractional uncertainty of the other variables. Now all I need to do is to just put the values and get the answer. Now you see, I do not know the uncertainty in area, so I will keep this uncertainty in area as it is. But I know area. I just figure out I know the value of area, so I would write 0.2463 as it is. That will be equal to plus minus 2 times. I know the uncertainty in D, which is given in the question as 0.01. So I will write 0.01 as the uncertainty, and I will divide it with the actual value of D, which is 0.56. And now if I further simplify this, I will get uncertainty in area equals plus minus 2 times 0.01 divided by 0.56, and this whole term being multiplied with, you see this 0.2463 is getting divided with the error on the left hand side. When I will move it to the right hand side, it will get multiplied. So I will have 0.2463 getting multiplied with the whole term. And now if I calculate the final value, I will get the answer as 0. plus minus 0.009 millimeter square. So we always write the final answer. We always write the final answer in one significant figures only. Now, so I know the value of area and I know the error. So this is the error and this is the value of area. Now how I am going to finally represent the answer? So I am going to represent my answer as area plus minus the uncertainty in area. Now remember, because I have my error in 3 decimal places, after rounding it off to one significant figure. You see, when I round it off to one significant figure, this is 0.009. Always remember, we will round off the uncertainty to one significant figures only. So I have rounded off it to one significant figure, so I'll get 0.009. Now after rounding it off, I will see how many decimal places do I have in the uncertainty. So I have a total of 3 decimal places. You see, 009, 3 decimal places in the error, in the uncertainty. So my final answer should also be in 3 decimal places. So rather than writing 0.2463, I will round it off to 0.246. I will not write 3 further. Why? Because now the answer is in 3 decimal place, plus minus 0.009, and this will become millimeter square. So this is how I am going to represent the final answer, and you can see that my calculation, the calculated value for area has 3 decimal places and uncertainty also has 3 decimal places. So while writing the final answer, we need to make sure that they both have the same decimal places, and the error should be rounded off to one significant figures only, and this is our final answer.